Yes? Are we ready to continue?
Yes.
Grace? Amanda?
Yes.
Are you sure you're ready to continue?
Yes. I'm very sure.
You're very sure. Great. Grace is not so sure.
I'm thinking now.
What are you thinking about?
Homework is one page or two page?
What do you think?
Two page. Thank you. Can I go back to the title?
By the way, Grace, this lesson is the only lesson that has no homework.
Wow.
So you asked me, no homework, only one homework? No problem. This lesson has no homework. Yeah? So lucky for you. Yes, lucky for you. Okay, continue. Conservation of energy.
Yeah.
Right. So, can you see that picture there?
No.
No, it's for the electricity to your home. Can you see electricity? Pylons? Yes. What's wrong with her? Can you see?
Yes.
All right. So we know this word in English, don't we? Energy.
Yes.
Yeah. She has no energy. Yeah. So if something has energy, what would you say? If something has energy, how do you know something has energy? Superman definitely has energy.
It's moving, have force.
Maybe it's moving, maybe it has a force, yeah, yeah. It can do work. It can move, it has a force. So, what do we mean? So what exactly do we mean? Something has energy if it can do work. So if it has energy, then it can do work. If it can do work, it has energy. So you are all working right now, mostly.
What is something is energy?
Yeah, something has energy or something is energy. Both possibilities.
What do you mean is energy?
Like heat is energy because heat can do work. Amanda has energy because she can do work. It's a verb thing. Yes? Continue?
I have no energy.
You have little energy. If you had no energy, you would be dead. Yes. So you have little energy.
Yes.
Yes. Okay. Right. So we measure energy also in joules. No surprise. So, no work, no energy. No energy, no work. And the work that's done is always less than or equal to the energy available to do the work. So for example, if I have 100 joules of energy, that means I can do 0 to 100 joules of work. Yeah.
Can do work more than
Impossible. Impossible, yeah. I think about it like a bank. You know, if you have 100 euros in the bank, you can only spend 0 to 100. You can't spend more than 100. Yep. Is that okay?
Yes.
Yeah. So for example, if I have, I wake up and maybe I start the day with 1 million joules of energy. As I do work during the day, that energy I mean, I can't do more than 1 million joules of work. So that's kind of like my limit, you know. The work done must be less than the energy it has. If it has no energy, it can't do any work. If it has little energy, it can only do a little work. Yeah. All right. For example, if I have 1 million joules of energy, I can do at most 1 million joules of work, and no more. Okay. Often the problems we look at, the work and the energy is the same thing. That you do all the energy is converted to work. So sometimes I switch the words. Sometimes I say energy. Sometimes I say work. Often they're the same in the question. So often work equals energy. Often. Not always. Often. Okay, there are many types of energy. That is, there are many types of things that can do work. Okay, you don't need to really write that down. Get ready. We shall look at them. Okay? So, the first type of energy, briefly look at them. The first type of energy is electrical energy. This, of course, can do work. It can make light, it can make heat, it can move things, it can cool food in the fridge, you can heat food in the oven, you can boil water, you can move in an elevator, you can move in a car. Electrical energy definitely can do work. So this is the first type, electrical. Did you write that down? Yeah. Okay. The next type, magnetic. So this picture shows that magnets can do work because the magnet lifted the metal. You've seen these before, haven't you? Like the car, and the car gets lifted up. So this is a force and the distance. So is it doing work? Definitely. So it has energy. So there's magnetic energy. Yep. Right. Chemical energy, the most delicious of all energies.
What's the cake energy?
Or cake energy, yes. Chemical energy is much more delicious than electrical or magnetic energy. Trust me. Yeah. So this is the one that's really important, for living. This energy, it gives you the energy to live, to move, to do things. Okay. So chemical energy, usually food. Okay. Now, radiant energy is like radiation, energy from light.
Can we call it light energy something?
Yeah, that's fine.
Sun.
Light. So, like for example,
Sun's light.
more like the sun though, but true. Here, yeah. Like here, you see this?
Yes.
It takes the energy from the light. So the light has energy because this can take that energy and it can do work.
Is this energy from sun?
Yeah, energy from the sun.
Only?
Well, it's energy from the light, but that's really, really small. So it's more from the sun. Yeah. Like there's not much energy in that. Like this here, maybe it's like 1 joule. It's really small per second. Yep. Okay. Nuclear energy. Yep. So we know this energy, like in the power plant. Yeah. Very powerful energy. Yes. Okay. Now, ionization energy. You know this one from chemistry.
I don't remember.
I know you don't. But you know that when you want to move the electrons up or down, you need to give it energy. If the electron moves, let me think, down, does that give you energy or does it take energy?
It gives.
It gives energy. And if the electron moves up, you must give it energy. Yeah. So, huh? What's wrong? Question?
Dr. Lorraine asked us to ask you
Yes?
a chemistry question that is related to physics.
What was the question?
I forgot what it was.
You're no good.
No.
Yeah, do you remember?
Why the electron from the
Oh, yeah.
EG? Why when
Why
it jump?
did it why when it jumps from T2G to EG, why doesn't it go back to T2G?
Oh my goodness. When it jumps from where?
To
T2G.
T2G to EG.
Wait, slow down. D.
You
What?
like the
T2G.
subshells of d orbital.
Yes?
The like
The
when it,
subshells of the d orbital,
orbital.
when it receives light,
Yes?
it separates to the T2G orbital and the EG orbital.
Yes?
So there'll be a couple of electrons in the EG orbital and more at the T2G
Yes?
orbital, which is a lower energy.
Yes?
So why doesn't the electrons from the EG orbital go back to the T2G orbital?
It's complicated. And I don't know.
Okay.
This is the one where there, in certain situations, it does something strange, and instead of going up a shell, it goes down, isn't it?
oh, it's the
No,
color
because
effects.
it like the color we see is because of the light that is absorbed by the T2G
Yes.
and EG electrons. So
So let me just get this straight. Where does it start? D.
yeah, it starts with a d orbital.
D.
Yeah.
No. I think
No.
Like
No, it separates from a d orbital.
like it's write 2 blocks and draw 3 blocks.
yeah.
Two.
No, like it's square blocks.
Square.
Yeah.
All right. I'll draw a square.
2 square blocks.
2 square blocks.
Like
You can
Attach
draw a little, not very big.
like 2 columns.
Square.
Columns. You can say 2 square.
Small one.
Yeah.
Yeah.
And now a 3 columns.
3 rows.
Yeah, 1 row, 3 columns.
What are you doing?
1 row, 3 columns.
Like
Ah,
T2G and EG.
show you
Like,
the picture.
Show me the picture.
Yeah.
Yeah.
Just show me the picture.
Very.
Terrible. Terrible.
Yeah. Yes.
Oh.
T2G, EG, and electrons will jump from the T2G to EG.
Yes.
But why the electrons don't jump back?
The electrons jump from T2G to EG
Yeah.
when you give them energy.
Yeah, when they receive light.
Yeah. So the question is, why don't they jump back?
Mm-hmm.
Yeah.
Well, why would they jump back?
Wait.
Question is why didn't they?
Yeah, so that's what you're asking.
But why would they jump back?
Because there is no more energy. Like when the light is off and stuff, something like that, right?
Just like in here, low spin state, electrons are all in
Yeah.
T2G.
And then they jump up.
They jump up, become a high spin state.
Some light shines on them,
I don't know.
Maybe.
Yeah, due to light.
and it jumps up.
And
Due to some energy source.
Yeah. So why would it jump back down?
Just
Like when energy source
two
is diminished.
electrons jump to the
Also because
EG.
the energy source is always also changing,
So why
but why
it's not
doesn't it go
come
back
back
up?
to T2G?
But I'm not sure why it should jump back, because if it starts at this energy level and you give it energy, it moves up to
Yeah.
higher energy level. The only way it would fall back is if it then loses energy.
Lose energy?
Yeah. But I think it doesn't fall back. The higher orbit must be more stable or something.
Lower
No.
orbits are more stable.
The T2G is more stable. Yeah.
Oh, I see. This is the question. So the higher orbit should be more unstable. The lower orbit is more stable.
Yeah.
Why doesn't it fall back?
Yeah.
I don't know.
So if Lorraine gets up,
And
ask
we
us,
say,
we just say,
Steven don't know.
it has something to do with quantum physics. Yeah. It's, and I have a feeling if I was to look this up on the internet, the answer would be very complicated. Very complicated. So if you want an easy answer, I can't give it to you. It's complicated, yes. Alright, can I go to the next one? So we have ionization, which we have just talked about. Yeah. And now we have elastic energy. Grace, what are you doing?
QQ.
You on QQ? Ren?
Ring.
Ramen.
Ring. Why you know the ring?
Elastic energy.
I know many things.
Elastic energy and potential energy are.
Yeah, it's a similar idea. So here, this can do work. You know, you could break somebody with this. So this can do work. Elastic energy.
What do you call this thing?
Oh yes, hang on. Slingshot.
Yeah.
Skinshot.
Slingshot.
Slingshot.
S-L-I-N-G. Slingshot.
S-L-I-N-G.
G.
You what?
You want to know the name of this?
Yes.
Really? Alright. Sling shot. You have these in China?
Yes.
Or Pakistan?
Yeah.
Malaysia?
Mm-hmm.
Yeah. You do? Okay. Korea? Yes. Universal. Okay, next. Gravity. Energy from like the earth pulling. Yes? Okay. Heat. Energy you wanted this morning. Important energy. Yes? Okay. Mechanical. Yes? Got that?
Yeah.
Wave energy. Now, waves can take many forms. This is an ocean wave, but we have sound waves, light waves, many types. More about that later. Kinetic energy. This is the energy from moving. If something is moving, it has energy. Yeah? Okay. Potential energy is the energy because it could fall. This has energy because it could do work. It could kill him. So it could do work.
Potential energy is going down.
It could fall down, so it has energy.
Potential energy is mainly due to height.
Well, for us it will be just due to height, but of course there's other types of potential as well. But yeah, for us it will be height. What you doing?
QQE.
No QQing, please. Alright, next. This is the most important idea in physics. It's called the conservation of energy. And it says energy cannot be created or destroyed, but it just changes from one form to another. Okay, let me give you an example. So, oh, this is taking a long time to write down. Yeah? Yes?
From one from to another.
Yes. Yes. Let me explain. So, in the morning, I have my breakfast. This gives me, let's say, 1 million joules of energy. When I walk, maybe I do 500,000 joules of work. But there's heat coming off of me. Maybe this is also 500,000. So what I'm saying is, it's like money. Okay, if I have 10 euros and I buy coffee from you and cake from her, I give her 2 euros, I give her 3 euros, and then maybe I give Sophie 5 euros. In total, there's still 10 euros. It's just in a different form. Okay, so like the electrical energy here, it just changes into light energy and heat energy, and here, what else do we have? Not much else. Laptop, yeah.
Mechanical
The
energy.
mechanical energy or something. I can't think of what else in this room is interesting. The heat energy is here. So I'm moving. Where did my energy come from? It didn't just
Chemical.
yeah, it came from chemical. Chemical energy which came from the food I ate.
Yeah.
So let's say for breakfast I had a pig for breakfast. Okay? So right now I have energy I got from chemical energy. Chemical energy was in the pig. Where did the pig get its chemical energy from?
The food.
From eating its food. What food?
Grain.
Grain. Where did the grain get its energy from?
Light.
Light. What light? The
Sunlight.
sun. You know, so the
And
energy.
where did sun get energy
Yeah,
from?
you can
From
keep going.
fusion.
You can keep going backwards and backwards. Yeah. The energy doesn't just appear. The energy must be transferred from something else. So if I have 10 euros, I didn't just go, poof, 10 euros. That would be nice if I could. I can't do that. So if I have 10 euros, it's because I got it from someone else. My boss, from you, from the shop. I didn't just make 10 euros. It came from somewhere else. So this is the most important idea in physics. That energy just transfers. It doesn't, it's not created, it's not destroyed, it transfers. Do you understand? Yeah? Okay. That's it. There's no homework for this one.
Okay.
I need chemical.
You need chemical energy, yes. And you also need heat energy.
Yeah.
Yeah.